Talk about solving trig functions. I'm going to do the first one, and then I will leave you to deal with your own after that. Solving, what is solving first of all? If I'm asking you to solve something, what I'm asking you to do, find out what x equals. We know with trig functions, what do we know about trig functions? What do they do by nature? They repeat, correct? So when I ask you to solve this immediately, do you think there's going to be one response? Is there going to be one answer? No. There could be an infinite number of answers, correct? Is that correct or not?
Yes.
In this scenario, though, there is not an infinite number of answers. Why is there not an infinite number of answers? Haley?
Because you've limited it.
I've limited the domain, correct? Between 0 and 2 pi. What does that mean? It means I'm doing one full rotation. Where do I start? 0. Where do I finish? 2 pi. In this scenario, I've gone 0 to 360. What's different? I'm in degrees in this one. Negative pi to pi. So it starts at negative pi and it works its way around to pi. Cool? Still a full rotation. We're just getting used to where it starts and where it finishes. So with any solving, what do we need to do? What are we trying to get? X by itself, correct? So I want to get rid of this sine function. How do I get rid of a sine? Inverse sine, so I have sine negative 1 of sine x equals sine negative 1 of root 3 on 2. Are we happy with that? Now, if this was a tech active exam, what could I do? Shove it in my calculator. Let's assume it's not though. It's not a tech active exam, it's tech free. Am I able to solve that? Yeah, it's just about using our unit circle and our exact triangle. So if I come over here and draw a couple of triangles, which triangle am I using? What one? The 30, 60 or the pi on 6, pi on 3? Okay. Which angle am I dealing with here? I've got sine, which means opposite over hypotenuse. So I need the angle opposite this side, which is this one here, which is my pi on 3, correct? So I ask myself, where is sine positive? In what quadrants?
Top right.
Draw my cast circle if I'm unsure. So I know my key angle is pi on 3. So that's going to be there. Where else does it occur? In the second quadrant, correct? So I know this angle here is going to be pi on 3. Do I want that angle there or do I want the total angle? What's the total angle here? 2 pi on 3. So I know that x equals pi on 3 or x equals 2 pi on 3. Are they all my solutions? Have I any other solutions for that?
Oh, is that it?
That's it. Does that make sense? We've done something similar to this before. Would you like another example? Because I consider there are some confused faces in the room. I'll give you one where it's not going to be in the first and the second quadrant. Give me I can do the second one. Actually, I'll do the second one and then I'll go from there. So the second one, I might just rub this last one out so I've got some space to operate in.
Wait, so what about the sine negative 1? Why does it like disappear?
Why does it what?
Like leave?
Well, it's what we're doing without our calculators. This is what our calculator will pop out. If you shove that into your calculator, you'll get this as the response. Cool? So again, first step is to isolate x. How do I do that? Inverse tan. So I've got x equals tan negative 1 of root 3. What's my next process? What triangle am I using?
36.
A 30-60, so I draw my 30-60 triangle, probably a bit bigger this time so we can see what's going on. Let's draw a 30-60 triangle. And in this case it is a 30-60 triangle because we're dealing with degrees. Tan is equal to what? What's tan equal to? What over what?
Opposite over adjacent.
Opposite over adjacent. So what angle am I dealing with? I need the angle that's opposite this. What angle is opposite that?
60.
60. So I know my key angle Sorry, that's negative 3. Negative root 3. My key angle is?
60.
I might even write that down. Key angle is 60 degrees, correct? So now what do I ask myself? Where is tan?
10.
Yeah, what quadrant is tan negative in? And the answer to that question is?
Top left and bottom two.
Yeah, the second and the
Fourth.
fourth. So I know this angle here equals 60. I know this angle here equals 60, but that's no good to me. What do I actually need?
The opposite.
I need the full angle, don't I? I need this angle here, and I need this angle here. So what are those angles?
120, 300.
Well, how do I figure it out? How do I figure that out?
180 and 50.
Very good. So x1, my first value for x, equals 180 degrees minus 60 degrees, which is 120 degrees, correct? What's my second value? x2 equals? Don't tell me the answer, tell me how I get there. x2 equals what, Jason?
360 minus 180,
Minus 180 or minus what?
whatever the number is, 60.
Yeah, very good, sorry. Yeah, no, that's right. I knew your process was good. 300 degrees. So they're my two solutions for that. Are there any more solutions? Or is that it? Yeah.
I guess you could do negative 60, but that's when
Outside my domain. Very good. Yeah, I could do negative 60, but that's outside my domain. I think we might go with a couple where I'm not asking us to do negative degrees to start with, and then I'll build up the negative. Happy with that?
Can you do one more example?
Yeah, I'll do one more example on the board. I just won't film it. And I'll give some examples for those who want to charge up. Cool? So I'll throw some questions up on the right-hand side, and if you want another example, I'll go through that slowly.